Welcome to my channel Chemistry Tutorials by Kiranmai. Today in this video I am discussing about shapes of atomic orbitals. Scientists found that different atomic orbitals have different shapes. That is, we have different atomic orbitals like S, P, D, F. These orbitals have different shapes. These shapes are mainly due to the probability density of finding an electron is different in different orbitals. Scientists drawed a graph between the wave function and the radius means the distance between the nucleus and the electron, and the graphs obtained for different orbitals showed that they have different shapes. Let's see what is meant by the wave function. Wave function is a mathematical function which is used to describe quantum state of a particle. So it is a mathematical function that describes quantum state of a particle, which is in turn defined by the values of its quantum number. Means as we discussed earlier, if we take the electron, we can say the exact location of an electron, like which orbital the electron is present, which suborbital it is present, uh, in which orientation it is. Like that we can describe an electron location using the quantum numbers. So to describe this quantum state of a particle, we use wave function. This wave function depends on momentum, time, position and spin. So it will change according to momentum. Wave function also changes according to time. Wave function changes with the position of the particle. Here if we take it's an electron, if electron is nearer to the nucleus, wave function will be, it will have one value. If it is farther from the nucleus, it will have another value. So it depends upon the position, and also it depends upon the spin of the electron. So wave function is a mathematical function that describes quantum state of the particle. Simply we can say that the location of the particle in space. Particle in space. Scientists drawed a graph between wave function as a function of radius. Wave function as a function of radius means wave function depends on radius. In maths we will be saying f of x as function of x, like that. Means we to describe a dependent variable which is dependent on independent variable, we use the term as a function of. Suppose I will explain with one simple example. Outdoor temperature. Outdoor temperature depends on month of the year. If we say outdoor temperature depends on month of the year, here we are using two terms. One is dependent one and another one is independent one. Here outdoor temperature depends on month of the year, but month doesn't depend upon outdoor temperature. So according to the month, the outdoor temperature gets changed, but not according to the outdoor temperature, month is changing. Similarly, wave function as a function of r. R means here the distance between the nucleus and the electron, radius. Wave function means psi. So wave function changes accordingly with the radius. So to describe this, we are using the term as a function of. So wave function as a function of radius. Scientists plotted a graph for different orbitals. 2s orbital. Wave function as a function of r. And then the radius. For 1s orbital it is like this, for 2s orbital it is like this. So both have different plots. Later, German physicist Max Born said that square of wave function gives the probability density of the electron. Probability density means we can say that electron will be 90%. There is a chance for electron to be here 90%, like that probability will be obtained by squaring the wave function. So again, scientists drawed a graph between square of the wave function as a function of radius, and they notice that for one s orbital where the principal quantum number n is equal to 1 and azimuthal quantum number l is equal to, for s orbital it is 0, probability density is more at the nucleus. So it is the nucleus, origin point nucleus. So probability density is maximum. While moving away from the nucleus, it got decreased sharply and then it reached 0 for 1s orbital. For 2s orbital, it is quite different. 2s orbital, n is equal to 2 and l is equal to 0. At first, they noticed the maximum probability density, which decreased sharply as the distance between the nucleus and the electron increased and reached the minimum value, that is 0, and then it again increased to some extent and then decreased again and reached the point 0. So there is some distance, there is some um, space where the probability of finding an electron becomes 0 between 1s orbital and then 2s orbital. So here is the 1s orbital and here is the 2s orbital. In between 1s orbital and 2s orbital, there is a gap where the probability of finding an electron becomes 0. Such regions is known as nodes. So imagine that the nucleus is present and then surrounding which the probability of finding an electron initially is very high. As the electron moves away from the nucleus, at certain extent probability of finding an electron becomes 0, and again moving further, again electrons probability will be increased to maximum extent and then it is decreasing to 0. Means it's like a cloud, one cloud where the electron probability is more. Again we have a space, empty space, where the probability of finding an electron becomes 0, and again we'll have another cloud where the probability of finding an electron will be maximum. The region where the probability of finding an electron becomes 0 is called node or nodal surface. Node is a surface or the region where the probability of finding an electron is 0. There are actually two types of nodes. They are angular nodes and radial nodes. Radial nodes. So radial nodes are the spherical regions. Spherical regions where the probability of finding an electron is 0. These radial nodes will have fixed radii. They will have some fixed radius. The number of radial nodes can be calculated by using the formula number of radial nodes is equal to n minus L minus 1, where n is the principal quantum number, L is azimuthal quantum number. Angular nodes are the flat surfaces. flat surface, or it may be a cones. Flat surfaces or cones where the probability of finding an electron is 0 are called angular nodes. Number of angular nodes is equal to asymptotal quantum number L. So, if we want to calculate the total number of nodes, we can add angular nodes plus radial nodes. So, total number of nodes is equal to radial nodes plus angular nodes. Radial nodes is equal to n minus L minus 1 plus angular nodes is equal to L. So plus L minus L, n minus 1. So number of nodes is equal to n minus 1, principal quantum number minus 1. So if we see this 1s orbital, we can see that there is no nodes, means there are no two electron clouds in between which the space is where the probability of finding an electron is 0. So for ns orbitals there is no nodes. Let us check. Ns orbitals formula n minus 1, number of nodes is equal to n minus 1. So n is equal to 1 minus 1, that equal to 0. So there is no nodes in 1s orbital. For 2s orbital, from graph we can notice that there is one node. Let us check with formula. 2s is equal to n minus 1, n is equal to 2 minus 1, that equal to 1. So there will be one node. Okay. After plotting a graph, scientists made a three-dimensional diagrams, charge cloud diagrams. For 1s orbital, it is like this. At the nucleus, the probability of finding an electron is more. As moving away from the nucleus, the probability of finding an electron will becomes less, and at particular point the probability of finding an electron is 0. And then for 2s orbital, initially at nucleus the probability of finding an electron is more and becomes less and then becomes 0, and then again the probability of finding an electron slowly increases and then reaches a maximum point, and then again it gets decreased. So here you can observe that white space where the probability of finding an electron is 0 is a node. This is a charge cloud diagram. For our convenience, expecting the 90% probability of finding an electron, we draw boundary surface diagrams. Surface diagrams. Here you can ask, can't we draw the diagrams with 100% probability density? The answer is no. Why? Because the probability density value becomes 0 at longer range, which will not have a particular shape. So to get a clear picture, we are considering only 90% of the probable density. So when we draw a boundary surface diagrams for 1s orbital, it look like this. 1s orbital. For 2s orbital, it is also a spherical shape. Here I am drawing 2D picture. Just imagine that one in 3D. In 3D, it's a spherical shape like a ball, football, like that. It's a spherical shape, but comparatively 2s orbital will have a larger shape or bigger shape than 1s orbital, but both will have the same shape, spherical shape. So this is about s orbital, shapes of s orbital. When we come to p orbital, boundary surface diagrams of p orbitals will have the shape of a dumbbell. At center there is a nucleus. On either side of the nucleus there are two sections called lobes. This is the shape of p orbital. Let us consider 2p orbital. For 2p orbitals, principal quantum number n is equal to 1. Principal quantum number n is equal to 2 and L is equal to 1. Asymptotal quantum number L value for s orbital is 0, p orbital is equal to 1, for d orbital it is 2. So asymptotal quantum number L is equal to 1. So magnetic quantum number ML, which describes the number of suborbitals, will have -1. Magnetic quantum number will have -1, 0, plus 1 values. So totally 3 suborbitals: px, py, pz orbitals. Let us look into these boundary surface diagrams for px orbital. X, y, and then z. These orbitals, p orbitals, are for px orbital, the electron clouds orients on x-axis, axial orientation, only on axis it is oriented. Px axis, the two lobes are oriented on x-axis. So if we take this one as x-axis, this one as y-axis, green sketch, and then this one blue sketch as z-axis, electron is orienting only on x-axis. Here one lobe, here one lobe, x-axis. So px orbital. And then for py orbital, x, y, z, electron cloud gets oriented only on y-axis, py orbital. For pz orbital, x, y, z, electron get cloud oriented on z-axis, pz. These suborbitals will have different orientation of electron clouds, but these three suborbitals will have same energy and same shape. So dumbbell shape. Let us calculate the number of nodes. Number of nodes is equal to n minus 1. For 2p orbitals, n is equal to 2. So 2 minus 1. So there will be one node. Next, if we take 3p orbital, in case it is 3p orbital, will have 3 minus 1, that is 2 nodes. Here 2 nodes will be one spherical node. See, one, if we take 1s orbital, the gap between 1s orbital and 2s orbital will have one node. Similarly, if we take 3p orbital, 2p orbital, the gap between 2p orbital and 3p orbital will have one node, and then one node from the angular node, which I will be discussing now. So I will explain this. First, look at 2p orbital. 2p orbital will have one node, where the node is the angular node. Why? Because the radial node will be n minus l minus 1. So 2 minus 1 minus 1 means 0. So there will be no radial nodes. The node which is present in 2p orbital is a angular node. As we discussed earlier, angular node means it is a flat surface or a cone. where the probability of finding an electron is 0. So here let us look at px orbital. For px orbital, there are three surfaces: xy, yz, zx surfaces. So xy, yz, zx surfaces. While representing a graph, we'll say that if we are drawing a graph and we are pointing the particular point in xy region, we describe in x, y. Similarly, here also we are calculating probability density in the region xy surface. So here the electron cloud is present on x axis. Okay, on x axis the electron is present. So on xy region, here x axis will have a electron, so here the probability density doesn't become 0. So probability density is not equal to 0. In zx axis, zx surface also, on x axis we have electron density, so in this surface also we can find an electron. So probability of finding an electron y square is not equal to 0 here. In yz surface we cannot have an electron. That means the electron is absent in yz surface, so electron probability here becomes 0. Where the surface, the probability of finding an electron is 0 is called angular node. So it will have one angular node. Next, in py orbital, here also we have three surfaces: xy, yz, zx. If we consider these three surfaces, we have electron on y-axis. So when we have an electron on y-axis, xy surface also have electron, yz surface also have electron. So probability of finding an electron in these surfaces is not equal to 0. But yz surface will not have electron, so here the probability of finding an electron becomes 0. So zx surface is a surface where the probability of finding an electron is 0, so it becomes an angular node. Similarly, in pz orbital, if we consider the surface xy, yz, zx, here the electron cloud is oriented on z axis, so here we can find an electron. So probability of finding electron is not equal to 0 in yz plane and zx plane. In xy plane we cannot find an electron, so it becomes the probability of finding an electron is equal to 0. Here the probability of finding an electron is not equal to 0. Here in this the probability of finding an electron is 0. So here also we have one angular node. Let me explain. X axis, y axis, and then z axis. When electron cloud is present on x axis, we cannot find electron on y axis and z axis. So the plane where the y z is there, the probability of finding an electron becomes 0. So it will have one angular node. Similarly, in py orbital, here the probability of finding an electron is maximum in y-axis, but in zx plane the probability of finding an electron is 0, means electrons is absent in this plane, so it will have one angular node. In pz orbital, electrons are oriented on z axis, but we cannot find electron in x y plane, so this becomes one angular node. So this is about nodes in p orbital, and the shape of p orbital is dumbbell shape. All these p orbitals will have same energy levels and the same shape, but the orientation will change in x, y and z orbitals, px, py and pz orbitals. This is the boundary surface diagrams for p orbitals. Next one, boundary surface diagram for d orbital. One thing I forgot to say. As I said, for 3p orbitals we have two nodes. 3p orbital n minus 1. So 3 minus 1, 2 nodes. So px, py, pz. These three suborbitals will have one angular node. So here 3p means similar to 2s orbital. 2s orbitals means between 1s orbital and 2s orbital we can find one node. Similarly, for 3p orbitals, the gap between 2p orbital and 3p orbital will have one node. And again, for 3p orbital, particularly here 3p orbital will have one angular node. Like in px orbital, py, pz orbital will have one angular node. If we say for 3px how many orbitals are there, then we can say that there are two nodes, that is one node between 2p orbital and 3p orbital and another node in px orbital. So two nodes. Okay. Now let us see the boundary surface diagram for d orbital. D orbital. Let us consider 3d orbital. For 3d orbital, n is equal to 3, principal quantum number 3. Asymptotal quantum number is 2 and magnetic quantum number ml will have -2, -1, 0, 1 and 2. Means totally 5 suborbitals. We are naming it as dxy, dyz, dzx, dx square, y square, dz square. So these are the 5 suborbitals present in d orbital. The boundary surface diagrams for these orbitals are as follows. It will have a double dumbbell shape and one special shape in which there will be an axial orientation of electron cloud and also a ring of electron cloud. These are the two shapes present in the d orbital. So let us see in detail. X, y axis. We said that in p orbital the electron cloud is oriented on axis, whether it may be x-axis, y-axis or z-axis. But in d orbitals, the electron clouds are oriented on the non-axial surface, that is between x-axis and y-axis. So this is x-axis, positive coordinates, negative coordinates. So here the electron cloud is present between x-axis and y-axis. Non-axial orientation. And then the z-axis is present here like this, which I cannot represent on paper. So simply I am drawing this z-axis. So this is dxy. Similarly, for dyz, y-axis, z-axis, the electron cloud will be oriented non-axially between these two axes, and then for these two axes perpendicularly there is x-axis. If we consider dz x-axis, z-axis, x-axis, orbitals will be oriented non-axially, and then for this perpendicularly y-axis will be present. For dx square y square, for this the orbitals will be oriented on x-axis and y-axis, and there will be no electron cloud on z-axis. This is dx square y square. And for dz square, electron cloud is present only on z-axis. It is like p orbital axial orientation, and then there will be a ring of electron cloud around it. There will be a gap between these two electron clouds. This is x-axis and this is y-axis. The electron cloud is present only on z-axis. This is dz square. These are the boundary surface diagrams for d orbital. If we calculate the number of nodes for 3d orbital, number of nodes is equal to n minus 1, that is equal to 2 nodes. If we calculate radial nodes is equal to n minus l minus 1. N is equal to 3. For d orbital, l is equal to 2 minus 1. So radial nodes become 0. So number of radial nodes is 0. For angular nodes is equal to value is equal to azimuthal quantum number L. So for d orbital, azimuthal quantum number is 2. So number of angular nodes is equal to 2. So I will explain how the two angular nodes are present in d orbital. For d orbital, similar to p orbital, we are writing xy, yz, zx planes. As I said, the electron cloud is present only in xy region. Xy surface, the probability of finding electron is not equal to 0. Whereas there will be no electron in yz plane and xz plane. So two planes where the probability of finding an electron is 0 are considered as angular nodes. Let me explain. This is x-axis and this is y-axis. Electron cloud is present in between these two axes, but there will not be electrons on x-axis and there will be present between x-axis and y-axis. So for convenience I am writing like this: x-axis, y-axis. Electron clouds are present between these surfaces. And this is z-axis. There will be no electrons present in this region, y-axis and z-axis. No electrons will be present in this region. So the probability of finding an electron becomes 0. And again, if we consider the plane, flat surface between x-axis and y-axis, in this surface also the probability of finding an electron is 0, means no electron will be present in this surface. So this becomes one angular node. Z axis also will have 0 electrons. So probability of finding electrons becomes 0. Similarly, for DYZ, if we consider XY, YZ, ZX planes, here the electrons are present only in YZ surface. So it is not equal to 0. But in another two surfaces, XY and YZ, probability of finding an electron becomes 0. So these two surfaces becomes two angular nodes. In DZX, XY, YZ, ZX, the electrons are present in ZX surface only. So here it is not equal to 0, but there will be no electrons in xy surface and yz surface, so the probability of finding an electron becomes 0. So these two becomes two angular nodes. In dx square y square, see here the case is different. X square and y axis, electrons are present on axis, but see on axis, x axis, y axis, and this is z axis. There are only electrons on x axis and y axis, but there is a region here at 45 degrees angle. This region, I am pointing with pen, in this region, at angle 45 degrees, there will be no electrons present in this surface. So at 45 degrees angle, there will be no electrons. This is one angular node, flat surface. And again in this region, again at 45 degrees angle, there will be no electron cloud. So there will be two angular nodes in this case. Nodes. These two angular nodes are non-axial. And then when we come to dz square, here it is a z axis where the electron cloud is present. So here this is a z axis, here the cloud is present on z axis, and surrounding which there is an electron cloud. There is one electron cloud like a ring. So there will be a surface where here empty space where the probability of finding an electron is 0. See, this is z axis. Here the electron cloud is present as in p orbital, pz orbital, axial orientation, surrounding which there will be a ring of electrons. Here the gap, conical shape surrounding the z axis, there will be two cones where the probability of finding an electron is 0. As I said, angular nodes means the flat surfaces are cones. Flat surfaces are cones. Here the conical region where the probability of finding an electron is 0 is also considered as angular node. So one angular node, one cone, and second angular node, second cone. So there will be two angular nodes in dz square. So these 5d orbitals will have two angular nodes. Okay, if we consider these 5d orbitals, they all will have the same energy, but the shape and orientation of these electron clouds will be different. This is about the shapes of d orbital, p orbital, and s orbital in the atom. Hope you understood this video. If you have any doubts, please comment in the comment section so that I will clarify your doubts. If you understand this video, like this video and share it with your friends. Thank you.